Question number 19, exercise 3.3 of calculus with analytic geometry, that is written by Yusuf. From question number 1 till question number 18, you have to see the parts 1, 2, 3 and 4 of exercise 3.3. Now in this part, we have to solve the rest of the questions starting from question number 19. In these questions, basically, we have to face the indeterminate forms in finding the limits of a function. So when we will attain an indeterminate form like 0 by 0 or infinity by infinity, then we can use the L'Hopital rule. And what we do in the L'Hopital rule, we take the derivative of the numerator and the derivative of the denominator. So starting from this question, limit x approaches to 0, ln tangent x over ln x. When we put 0 in place of x here, ln, it will become ln tangent 0 divided by ln 0. We know that tangent 0 is basically 0 and this is ln 0 again. So this is ln 0 ln 0. So it is infinity by infinity form because ln 0 is undefined. Using the L'Hopital rule, take the derivative of the numerator. The derivative of ln function is always 1 over that function and the derivative of that function separately. So 1 over tangent x and the derivative of tangent x is secant square of x. Now the derivative of denominator is 1 over x and the derivative of x is 1. Rearrange the terms. 1 over tangent x can be written as cot of x. Secant square is written as it is and 1 over x as it is. Now open these terms and simplify more. Cot of x can be written as cos of x over sine of x into secant square of x is 1 over cos square of x and this is 1 over x. Now this cos of x cancelled with 1 of this cos of x. We will be left behind 1 over cos x sine x divided by 1 over x. If we further simplify this term and convert this division sign into multiplication, then take the reciprocal of this term and then simplify the fractions. We will get x over sine x cos of x. Now put x is equals to 0 in this fraction, we will get 0 by 0 form. This is again an indeterminate form. So here we can use the L'Hopital rule. So after using the L'Hopital rule, that is take the derivative of the numerator, that is 1. Now for taking the derivative of denominator, we have to use the product rule here. Sine of x will give us cos x. This cos of x will remain as it is. Plus now this first term will remain as it is. Take the derivative of second term, that will be minus sine x. Multiply the terms with each other. We will get limit x approaches to 0, 1 over cos square of x minus sine square of x. Use this limit that is approaching to 0 in place of x. We will get cos of 0 is always 1 and sine of 0 is always 0. So 1 minus 0 here. So we will get 1 value. Question number 20. Limit x approaches to 0, log tangent x tan 2x. Now this tangent x is basically in subscript of log. This whole function can be written in terms of ln, natural logarithm, and that can be written as this term, this main function will be written in numerator with ln and this subscript will be written in the denominator with this ln. ln tangent 2x and ln tangent x. Now put 0 in place of x. This will give us tangent 0. Tangent 0 is 0. So ln 0 will become undefined, that is infinity. Here in the denominator again we will get tangent 0, that is infinity. Use the L'Hopital rule. Take the derivative of numerator 1 over that function tangent 2x. So 1 over tangent 2x and the derivative of tangent 2x is secant square 2x and the derivative of this inner function 2. Now take the derivative of denominator, that is 1 over tangent x and the derivative of this inner function tangent x will be secant square of x. Rearrange the terms. I have written this whole numerator separately and just separated it from the denominator with this division sign. Change this division sign into the multiplication and convert this fraction into its reciprocal form. Just make the denominator numerator and the numerator as the denominator. Then we just have that fraction in the reciprocal form. Open all the terms, just simplify them. Secant square 2x can be written as 1 over cos square 2x. Tangent 2x is sin 2x over cos 2x. Tangent x is sin x over cos x, and secant square x is 1 over cos square x. This cos of x can be cancelled with this. This cos 2x can be cancelled with one of this cos 2x, and rearrange all the terms. We will get 2 sin of x cos x divided by sin 2x cos 2x. Now we know very well that this is an identity. This is equals to sin 2x. 2 sin x cos x is always equals to sin 2x. The denominator remained as it is. Now this sin 2x will be cancelled with this sin 2x. We will remain with 1 over cos 2x. Use this x value 0, limit value in this. Cos 2 0 is cos 0, and cos 0 is always 1. So 1 divided by 1 will give us 1 again. Question number 21. In question number 21, we have limit x approaches to a, x minus a cosecant pi x over a. Cosecant pi x over a can be written as 1 over sine pi x over a. So I have moved it in denominator and just changed it as sine of x, pi x over a. This is 0 by 0 form because when we put x approaches to 0 here, so a minus a will be 0, sine pi a over a and a will be cancelled. We will be remained with sine pi, and sine pi is sine 180 degree, and sine 180 degree is 0. So we got 0 by 0 form. Using the L'Hopital rule, limit x approaches to a, take the derivative of numerator, that is 1 minus 0. A is treated as a constant, so it has a derivative 0. Sine of x, here x is pi x over a. Its derivative will be cos pi x over a, and the derivative of angle is this, pi x over a. So when we take its derivative, pi over a will remain as a constant and x will give us derivative 1. So we got pi over a. We got 1 over pi over a cos pi x over a. This pi over a, it is in a denominator. When we move it up, so it will be just reverse. We will get a over pi. And we will left with 1 over cos pi x over a. Now, use this value of limit here in place of x. This a will be cancelled with this one. We will be left 1 over cos pi. Cos pi is equals to minus 1. So, we got minus a over pi in this question. Question number 22. Limit x approaches to 1, 1 minus x tangent pi x over 2. If we put 1 in place of x, we will get 1 minus 1, that is 0. Tangent pi into 1 by 2, that will be tangent pi by 2. We know very well that tangent curve have asymptotes at 90 degree. Tangent curve normally have the asymptotes at 90 degree. It means that is undefined at 90 degree, pi by 2. So this is an undefined value. So we got 0 into infinity. This is an indeterminate form. We will change it into 0 by 0 or infinity by infinity form. For that purpose, we have to rearrange it. Tangent pi x by 2 can be written as 1 minus x divided by 1 over tangent pi x by 2. This will make none of the difference. It is the same as it is the previous step. It can be moved up and we got the same previous step. 1 over tangent, this function is basically equals to cot pi x by 2. This is now 0 by 0 form. So we can use the L'Hopital rule. Take the derivative of numerator. 1 will have derivative 0 and x will have the derivative 1. Cot pi x by 2 will be minus cosecant square pi x by 2, and pi x by 2 will give the derivative pi by 2 into 1. Simply rearrange the term. We got minus 1 over minus pi by 2 cosecant square pi x by 2. Minus and minus will be cancelled with each other, and when we move this constant up here, we will just have the reciprocal of it, that is 2 by pi. 1 over cosecant square pi x by 2. When we move it up, we will get sine square pi x by 2, because we know that this is equals to 1 over sine square pi x by 2. So it will move up and we will got sine square pi x by 2. Put x as 1, we got sine square pi by 2, that is sine pi by 2 whole square. Sine pi by 2 is always equals to 1. So we got 2 by pi 1 square, that is always equals to 2 by pi into 1. So we got 2 by pi as the answer of this question. Question number 23. Limit x approaches to 0, x ln tangent x. Again we have here the indeterminate form, that is 0 into infinity. Just change it into infinity by infinity or 0 by 0 form. Here we got infinity by infinity form, so we can use the L'Hopital rule. Ln tangent x. This x can be moved down as 1 over x. So we got ln tangent x divided by 1 over x. Use the L'Hopital rule. Ln tangent x will give us 1 over tangent x, and the derivative of tangent x is secant square of x. Now we have to take the derivative of 1 over x. We know very well this 1 over x can be written as x raised to power minus 1. So when we take its derivative dy dx of x minus 1, power down, power minus 1, we will get minus 1 into x raised to power minus 2, that is minus 1 over x square. So here its derivative will become minus 1 over x square. Just rearrange the terms. 1 over tangent x will be cot of x, secant square as it is. This is 1 over in this form, so it can be moved up like minus x square. Again, simplify the terms. Cot x can be written as cos x over sin x. Secant square of x can be written as cos square of x. Just multiply all the numerators with each other and the denominators with each other. This will be cancelled with this one. We got x square. I have taken this minus sign outside because it is none of the any change in the problem. So we just have taken it outside. Limit x approaches to 0, x square over sin x into cos of x. Now we got, just take the derivative. Before taking the derivative, we can also simplify it further. How? Just multiply the numerator and denominator with 2. Multiply and divide with 2, because here we see we can make it in an identity form, sine 2x. 2 sin x cos x is an identity, that is basically sine 2x. Now put 0 here, you see we will get 0 by 0 form. Now our problem is become easier now, simplified form. So use the L'Hopital rule here. X square will give us 2x, sine 2x derivative will be cos 2x into 2. Just cancel 2 with this one. We got x over cos 2x. Put x approaches to 0 here. So 0 cos to 0. Cos to 0 is 1. So 0 over 1 will be 0. So 0 into minus 2 will also be 0. So we got 0 in the answer. Question number 24. Limit x approaches to 0, x tangent pi by 2 minus x. This is again 0 into infinity form. Just rearrange it, move this x down like we did previously in the last example, 1 over x. Use the L'Hopital rule, take the derivative of the numerator. That is easy as before we did in the last example. Tangent x, like here we have, in place of x we have pi by 2 minus x. So secant square pi by 2 minus x, and the derivative of this inner angle. Pi by 2 is constant, so derivative will be 0. Minus x will be minus 1. And the derivative of 1 over x, as we did in question number 23, 1 over x has a derivative minus 1 over x square. Rearrange the term. Secant square, this function is basically, when we move it down, it can be changed into cos square pi by 2 minus x. This x square can be moved up like x square. This minus and this minus will be cancelled with each other. We know very well that cos square pi by 2 minus x is equals to sine square of x. Just consider cos square pi by 2 minus x. We know very well we can write it like cos pi by 2 minus x whole square. Now here we can use the identity like cos of alpha minus beta. This identity. Just open it. This will be cos pi by 2 cos of x plus sine pi by 2 sine of x. We know cos pi by 2 is always 0. Sine pi by 2 is 1. So we got here 1 into sine of x whole square. So that is equals to sine square of x. Again using the L'Hopital rule, because we will get the 0 by 0 form here. Take the derivative of numerator and the derivative of denominator. Again, multiply. There is no need to multiply any number here because we already got 2 here. So 2 sin x cos x is sin 2x. Again, use the L'Hopital rule. This is just become just like same as the previous question. It will be 2 cos 2x, like derivative of 2x is 2, derivative of sin 2x is cos 2x into 2. Cancel this 2 with this numerator and denominator. We got 1 over cos 2x. Put x approaches to 0 here, the limit. We got 1 over cos to 0, that is 1 over cos 0. Cos 0 is always 1. 1 over 1 will give us again 1. Question number 25. Limit x approaches to pi by 2, tangent x ln sine of x. If we put pi by 2 here, tangent pi by 2 is infinity and ln sine pi by 2 is 0. Because sine pi by 2 is 1 and ln 1 is always 0. Indeterminate form. Just rearrange it. We got ln sine x, move this tangent x down in the denominator like 1 over this form. 1 over tangent x can be written as cot x. Use the L'Hopital rule now. Because we will get here 0 by sine of pi by 2 will be 1. 1 is ln 1 is 0. And here we will get also 0 because cot of x is 1 over tangent x, 1 over 0, 1 over infinity will also be 0. Use the L'Hopital rule. Ln sine x will be 1 over sine x and the derivative of sine x is cos of x. The derivative of cot of x is minus cosecant square of x. Now, minus cosecant square of x can be written as minus 1 over sine square of x. This sine of x can be cancelled with this sine of x. We got cos of x over minus 1 over sine of x. Now, this can be moved up because it is 1 over this form. We got minus sine of x cos of x. Now, replace the x with this limit value. We got minus sine pi by 2 and cos pi by 2. Sine pi by 2 is 1 and cos pi by 2 is 0. So, we got 0 in the answer. Question number 26. Question number 26 says limit x approaches to 0, 1 over x minus 1 over e raised to power x minus 1. This is infinity minus infinity form. Because 1 over 0 is infinity, 1 over e raised to power infinity. E raised to power infinity will also be infinity. So, 1 over infinity, this is e raised to power 0. E raised to power 0 because we have 0 here. E raised to power 0 is 1. So, 1 minus 1 will be 0 and 1 over 0 is again infinity. So, we will get infinity minus infinity form. Just take the LCM. We took LCM here. So, put 0 now. We will get 0 by 0 form. So, we can use the L'Hopital rule now. Take the derivative of numerator. E raised to power x will have the same derivative as the exponential function. 1 is a constant. So, we will get 0. In place of x, we will get 1. This is in the product form. So, use the product rule of differentiation. Take the derivative of x and keep the second function as it is. Now, keep the first function as it is and take the derivative of second function. Just simplify all these terms. We get e raised to power x minus 1 over e raised to power x minus 1 plus x e raised to power x, that is 0 by 0 form. Again, using the L'Hopital rule. E raised to power x has the derivative e raised to power x and 1 has the derivative 0. Take the derivative e raised to power x same. 1 will have derivative 0 because it is a constant. Use the product rule here now. Take the derivative of x and keep e raised to power x as it is. Now, keep x as it is and take the derivative of e raised to power x and simplify all these terms. We will get e raised to power x plus e raised to power x as 2 e raised to power x plus x e raised to power x. Take e raised to power x as common and just cancel it with each other. We will get 1 over 2 plus x. So, we will get, put the limit here, we will get 1 over 2 plus 0, that is 1 by 2. Now, we are going to stop here. For the rest of the questions, just you have to visit the channel and soon the next questions will be uploaded. Thank you so much.